In this video, we will discuss about the first theorem for our Lebesgue outer measure. Okay, so tutuloy na lang natin yung discussion natin sa Lebesgue outer measure. Okay. So let's have theorem 1. Theorem 1. Okay, so lagyan natin ng ating sa gitna. Okay, so for our theorem 1, suppose we have set A, subset of R, Rn. So naka-general na siya. So let's say this is a set with finite outer measure. Okay. Then, for any positive epsilon, there is an open set G. Such that this set A, is a subset of G. Yung given set A natin ay subset ng open set G. And if we get the outer measure of this open set, this will be less than outer measure of A plus epsilon. Okay. So ano yung gustong ipunto ng theorem natin? So una, sinasabi niya, halimbawa meron tayong any set na may finite Lebesgue outer measure. So nasa loob siya ng isang open set. At least one open set with arbitrary close outer measure kay A. Or almost the same yung outer measure ng G kay A. So, ano yung gusto niyang sabihin? Ibig sabihin, instead of dealing with the original set A, which is a closed set, so, mas madali or mas advantage gamitin yung open set G. Since they have almost the same outer measure. Almost the same naman, almost pareho yung outer measure nila. So instead of dealing with A, kay G na lang tayo. Bakit kay open set? Because we have a lot of properties kay open set instead of closed set. Okay. Now, let's prove this theorem. So for our proof. So given positive epsilon, so there is a covering. So let's say we have covering of A. Since we say that A has a finite outer measure, so may finite outer measure siya. So obviously meron siyang covering of A by close intervals. By close intervals. Let's say S is equal to set containing I sub K. So yan yung covering niya. Such that by the remark, kung naalala nyo yung diniscuss natin sa previous videos. So this sigma of S, which is equal to summation of the volume of I sub K, is less than outer measure of A plus epsilon over 2. Okay, so kung mapapansin nyo sa remark, this should be less than or equal. Okay, but to use the strict inequality, inassume natin na yung outer measure of A is finite. Finite dapat ang outer measure of A. So that's why we use strict inequality. Now, let's say for any K, we have I sub K star let's say I sub K star is an expanded version of I sub k, such that, so this I sub k is a subset of interior of I sub k star. Take note, nagamit na natin itong method na to. In-expand natin si I sub k into I sub k star with this restriction or with this condition. So first, paano natin siya in-expand? Yung interior ni I sub k star, nasa loob na nun si I sub k. Okay. And yung volume ni I sub k star is less than or equal sa volume ni I sub k plus epsilon of 2 raised to k plus 1. So this is a multiple of epsilon. Okay, epsilon multiplied by 1 over 2 raised to k plus 1. Okay. So next. So gumamit tayo ng another variable to set the union of interior of I sub k star. So let's set G to be the union of interior of I sub k star. Take note, hindi ako gumamit ng lower or upper limit. Okay, para naka-general siya. So whether it's an infinite or finite. Okay. So since G is the union of interior of I sub k star, so then we're talking about interior, which is open. Okay? Yung interior lang ni I sub k star. So this means that G, so thus G is an open set. Because if we get the union of all or countable collection of open sets, that is also an open set. Now, may proposition 2. Kung naalala nyo pa yung proposition 2 na diniscuss natin. So by proposition 2, we have outer measure of G is less than or equal to summation of outer measure of I sub k star. Okay. So yun nga, di ba sabi sa proposition number 2, kung naalala nyo yung proposition number 2, yung proposition ng, yung outer measure ng union, which is yung G, union of interior, that is less than or equal sa outer measure ng sum. Okay? Mas maliit daw yung outer measure ng union kaysa kukunin mo yung outer measure ng bawat isa saka mo ipagpa-plus. Okay? And isa pa, we're talking about union of interior kay G. This time, this is outer measure, summation of outer measure I sub k star. Okay? Now, take note that we're talking about closed interval kay I sub k star. So, because this is just an expanded version of I sub k. So, meaning, kung kukunin natin yung outer measure ng closed interval using proposition 3. So, by proposition 3, balikan nyo na lang yung proposition na di-discuss natin last videos. So, by proposition 3, ang outer measure ng closed interval ay yung volume niya. Okay? So, this is, tuloy natin, outer measure of G is less than or equal summation of the volume of I sub k star. Okay? Now, as you can see dito, yung volume ng I sub k star, that is less than ito. That is less than or equals to volume of I sub k plus epsilon over 2 raised to k plus 1. Okay? So meaning, this is less than or equal to summation of the volume of I sub k plus e raised to 2 raised to k plus 1. Okay? Now, the volume of I sub k is the sigma of S. Summation of the volume of I sub k is the sigma of S. So, pag in-expand natin to, imagine it. Okay? So, naka-plus lang din naman to. So, plus siya. And then, may hiwalay lang. Pwede nating i-separate lahat ng epsilon over 2 raised to k plus 1. Okay? So, parang ganito. Lahat ng mga epsilon, lahat ng mga volume, let's say volume of I sub 1 plus volume of I sub 2. Try natin. I-delete na lang natin. So, dito. Parang yung volume ng I sub 1 plus epsilon over 2 raised to 2 plus, ito yung una, volume of I sub 2 plus a raised to 2 raised to 3. So, as you can see, puro plus siya, no? So, parang ihiwalay lang natin to by associative. Ilalagay lang natin siya sa dulo. Okay? And then, after nating ilagay sa dulo, as you can see, mas malaki yung mga denominator nito. So, epsilon over 2 raised to 2 plus epsilon over 2 raised to 3 plus epsilon over 2 raised to 4 and so on. So, mas malaliit yung mga denominator niya although pinag-a-add natin siya. So, this is less than equals epsilon over 2. Only 2. Okay? So, meaning, balikan natin yung given natin. Okay. So, meaning, this can be less than or equal to sigma of S, which is the summation of volume of I sub k, plus epsilon over 2. Okay? So, tinanggal natin yung k plus 1 or yung 2 raised to k. So, parang dito sa epsilon of 2 times 2 raised to k, nalis natin to. Becomes epsilon of 2. Okay. Now, so this is now, take note, this is now sigma of S plus epsilon over 2. And pwede pa nating lakihan tong epsilon over 2. Let's make it twice. So this is now less than. And this is outer measure. Let's make it outer measure of A plus epsilon. Okay? Which is yung kailangan nating mangyari. So, outer measure of G is less than outer measure of epsilon, outer measure of A plus epsilon. So this is now done. Okay? So this is how we prove theorem number 1. And because of theorem 1, meron tayong nabuong corollary. So let's say this is our second corollary. So, corollary number 2. Okay. So for our corollary number 2, let A be a subset of Rn. Then for any positive epsilon, there is an open set G such that A is a subset of G and the outer measure of G is less than or equal outer measure of A plus epsilon. Magkaiba sila ng sinasabi ni theorem. So kay theorem 1, we're talking about strict inequality. Outer measure of G is less than outer measure of A. Because we're talking about finite outer measure. Okay? Now, kay corollary, pwede ang infinite. Okay, so that's why we have outer measure of G less than or equal outer measure of A plus epsilon. Okay? So, that's all for our discussion.